Okay, hello everybody. It's a pleasure to welcome you here to our first Hypnoid Talk. And I have here the honor to have our first guest, Professor Patrick Navarre. Welcome, Patrick. And thank you for
Hello,
accepting our
thank you.
invitation. Yeah, thank you.
Thank you very much for inviting me for this first Hypnoe Talks. I think that's a very interesting event, and I think there will be a series which will be probably very fantastic. I like this very much. And thank you very much for inviting me for being the first presenter. Thanks.
Yes, it's a great opening. Yeah. Patrick, I would like to start talking to you about the whole idea. I mean, what is the idea of Hypnoid? How did you create this concept? I mean, you were a successful scientist. You were also successful in politics, also in your city in southern France. And at a certain moment, you realized that, okay, I will take this challenge of traveling around Europe and in putting people together to one goal. So can you tell us a little bit about that? Because it's not very typical for a scientist to take this type of would say journeys. Eh?
There were several reasons for this. At the time where all this started, which is about the year 2000, before that I was working with conventional polymers coming from oil, mostly, and I realized that these polymers, oil-based polymers, they will have very soon some strong limitations. And one of the limitations at that time I was fearing was that there could be a shortage of oil, which turned out not to be true, by the way. But that was my thought at that time. And the second one was the potential dangers of oil-based polymers, oil-based plastics, regarding environment, regarding the global warming. And I was thinking that it could be the right time to move to something else. And the something else, which is of course obvious, is to take plastics, polymers, from the biomass, which is renewable, and which at that time I thought would be, of course, much safer. So that was the main thing. That was the main driver for me to change and to say, okay, that's the time. At that time, I was the head of my research group. I was the director of the Joint Research Center. So I had the freedom to move where I wanted. And I decided that that could be a good idea. There was a second motivation. I'm deeply convinced that in Europe, we must be all together. I'm a convinced European person. And I thought that it also could be a good idea not to do my research in my lab, but also to try to see if we could do it with sort of a more European side and way to do research. And there was an extremely good occasion. The European Union at that time, or the European Commission more precisely, at that time, launched a call for making networks. They call it networks of excellence, and we kept the name in Hypnoe. Networks of excellence. They said, okay, if you have an idea of a group of people in different countries, a group of scientists in different countries willing to study something, just answer the call. And this is what we started to do. But of course, many scientists wanted to do this. I think they received more than 10,000 applications. And of course, then it required time for me, mainly, to build an application with a meaning. First, we targeted only cellulose, but that was not a good idea. Then we expanded to polysaccharides. So that's the whole story. It started like this, with these two ideas. And as you said, I devoted about 3 months full time to travel and to visit many places. And we built it, and we won. We were accepted. Only a few hundreds were accepted, and it worked. Then problems started.
Yes, but one thing is interesting. How did you choose how did you select? I mean, it's not so simple, right? You just say, okay, today I'm going to build a big network with the scientists and so on, and I just go there, knock on their door and say, hey, do you want to join me? How was this process?
Well, it was a rather complicated issue for me. As I said, I was mostly working with conventional oil-based polymers. When I say mostly, it was not exactly, it means that I had a very limited amount of work coming from my PhD on cellulose. So that's why I chose cellulose as the first topic initially, because that was a topic I knew a bit. So it was rather easy to pick up a few groups in Europe working on cellulose. But when we started to expand to other polysaccharides, there my knowledge was extremely limited. And in addition, we had to go in areas where I knew nothing. Clearly, I'm working in a research center dealing with materials processing. This is a topic I can say I know a bit. But we were looking for groups working in food or in health, and I knew nothing there. So then that was a bit complicated. I had to rely on help from others. Some people, some scientists, some friends said, oh, look at that group. They are very good. Why not to contact them? And this is how slowly was built this story. And at the end, we were a group of 16 universities or research centers, and that was the core group. And that core group stayed where they are at the beginning. We were only 16 for many years for reasons I may explain later. We were not able to expand, but now we're expanding. But the 16 are still there, which is very great. Huh? More than 20 years after, the 16, they are there.
Yes, you managed to create a durable structure. I mean, that is also interesting. I guess you mentioned that some thousands of people applied for networks of excellence. Some of them got the funding, and some of them never continued. I mean, the network of excellence just disappeared because they were not able to create a durable structure. And that is something interesting, right? That you managed to create. It's something very important.
Well, I think that most of the networks of excellence disappeared. A few survived in a different way, but we survived. But there were two good reasons to continue, and we were able to continue. The first is that polysaccharides, this is a hot topic. So it means that we were able to have help from companies. In fact, to survive is a simple thing. We need money. That's not more complicated than this. If you have money, you survive. If you don't have money, you die. Okay, so most of the group, most of the networks, they stopped because after 4 years, there was no more money from the European Commission. So they just simply stopped. They were not able to do anything. So the first thing we did was to have the chance, let's put it like this, to work on a topic where companies were ready to help a bit. And the second, I was extraordinarily careful with money. So in a way that I was making the proper accounting, let's say, for us to be able to survive after the end of the help of the European Commission, because that was the main problem. After 4 years, for 4 years, we had a lot of money, 5 million euros. It's a huge amount of money. But then after, there was nothing. And then that was danger. And this danger was estimated right at the beginning. The first day we were accepted, my concern was, how shall we have money after 4 years to survive? That was the main problem.
Yes, it was.
But we managed.
It was a very interesting move, actually, based on good management. Yeah. But I would like to talk a little bit now about your career now, because it is quite interesting. I mean, you were a physicist, right? By education, right? So you studied physics, and then I see also in your career that you have done your postdoctoral research with the Nobel Prize. That is an authority in polymers. Actually, everybody knows Paul Fleury and the Fleury constants here, and so. So can you tell a little bit about your experience as a scientist? This is important for our young members, for people that are building their careers now. How do you see your career from coming from physicist and going more towards these natural systems involving polysaccharides and polymers and arrangements and so on. Can you tell us a little bit about this journey?
Well, it was not really a journey because I've always been interested by nature. Okay, so that's this. And during my studies, where I graduated in physics and physics of materials, in parallel, I was also graduating in biology. I have a master in biology also. And I was always interested by this. I never used that master, and that's vague knowledge for me because that's such a long time ago. But always I was interested by this matter. So it was a bit natural for me to move to polysaccharides. It was not something, it was not an abrupt shift. Always, all my career, I did my PhD on cellulose, even if there was nothing linked to biology at that time. Okay, it is coming from trees mostly, or for cotton or whatever, from plants. So there was this link, and this link was always present. So it was not really a deep shift. But I will tell you honestly what I thought. When I was young, for me, cellulose, polysaccharide, that was 19th century science. Okay, I was not. I was interested by nature, but you know, this cellulose, that was boring. There were so many interesting things at that time, in the 80s. There were liquid crystals. There were many interesting things. So I was more interested by this. I was working. You mentioned that I did a postdoc with Paul Flory, who was a famous Nobel Prize winner and one of the founder of polymer science. But in fact, I didn't work on polymers with him. I worked on liquid crystals. And I wrote 2 papers with him, but it was only on liquid crystals. He was also very interested by liquid crystals, how they were forming, why this liquid crystalline state. And if you look at my papers, probably 1/3 are on liquid crystals and liquid crystalline polymers. I was fascinated by this. And these polymers had extraordinary interesting properties. And at the moment, I was pretty sure that they will make a deep change in the way polymer technology and plastics will be done. And then it turned out to be a total failure because they are so well oriented that's extremely fragile. And then it is useless. They are very strong, but totally useless. But okay, that's life, you know. And then I changed. And then in the year, I moved then to other areas like blends, for example. I was very much interested by mixtures, blends, how things were arranged. And then in 2000, around the year 2000, I moved to polysaccharides. And of course, my first topics there were on cellulose dissolution, because I was intrigued by this. How can you dissolve cellulose? So,
yeah, and you had also nice papers on this work on cellulose dissolutions in sodium hydroxide systems. Yeah, it's interesting insights about the dissolution process and so on. Yeah, my students have been reading, and myself have been reading your paper. So it was a nice contribution.
I can tell an anecdote about Paul Flory. You know how it happened. I went once in a NATO school about polymer crystallization, in fact, not only polymers. And one of the professor there said, I met a guy working on polymers, a famous guy. He was not able to remember the name, but it was very clear it was Paul Flory. And he said, he's taking 1 postdoc with him per year. In fact, Paul Flory was a man who was working alone. He had only 3 persons, 3 collaborators, but not usually 2, not much, not many people. And he said, okay, why not? And then I thought, well, after my PhD, why not to do a postdoc? So I sent only 1 application, only to him. I didn't send only to that guy, and it worked. You know, that was it was even worse than this. He said, yes, I will take you at Stanford University with this salary. I look at this and I said with my wife, well, can we live with this salary? Why? We had a young child. Well, we said maybe not. So I sent him a letter saying, I'm very, very, that's grateful for you to offer me a position, but I will not take it. The salary is too low.
Oh, really?
And he said, okay, if that's the case, I will increase your salary. And then I went there.
Oh, wow, well, that is good.
Well, why to be shy?
That was a very good move also. Yes. Patrick, how do you see now? Yeah, you mentioned already the key polysaccharides. When you started now, you saw the future of polysaccharides. You saw a future for polysaccharides. And now, after interacting with all these scientists and deepening your research, how do you see from now on how this is going to evolve? How is the topic of polysaccharides be important to our society, to our well-being?
I was a material scientist, so my first concern, my first interest was to look at polymer materials, and I was thinking that polysaccharides could be an extraordinarily good source of polymers or polysaccharides-based materials would come and would be much safer than the oil-based polymers. But I'm not sure now this is exactly true. In terms of materials, there are huge, enormous opportunities to create materials from polysaccharides or from nature in general. But they have to be seen as creating new materials, not necessarily replacing the one which are existing now. And they are not necessarily much safer and much better for environment because they are coming from the biomass. And it is not absolutely true. And I think that's what was missing when we started this adventure, was to clearly assess the environmental benefits. And I think that's probably what will be the key point in future, which is to all the time assessing the interest and the advantages we do have by not using polyethylene, but something else, okay, PLA or whatever. And assessing the benefits are very important. And I'm very much afraid by the greenwashing and by the idea that because it is bio something, it will be very good. It's not the case. But there are a lot of opportunities in these materials. And for food, for health, for materials, and maybe from other disciplines, there are really huge opportunities. And if we would put the same efforts that were put when developing in the, let's say, 1955 to 1970 conventional polymers, a huge amount of money was poured in labs to create the new polymers, the one we are using every day now. If the same amount of money would be put for, and same amount of effort would be put to polysaccharides or to nature-based polymers, and assessing their safety and their environmental benefits, there are a lot of opportunities there. And this is a fascinating topic because it's not only speaking about physics, about materials, about chemistry, but also about biology. And this is very, very interesting to combine all this. And we need scientists that are able to speak with biologists, with agronomists. And this is fascinating and should be attractive for young students, because you have to master, or at least to be able to discuss and to understand very different sciences. And this is absolutely wonderful.
Yes, it is very important. Yeah, the greenwashing is an interesting story, because you see that there is a wave of new scientists coming to the polysaccharide area, the polysaccharide field, and they are really excited about all the great potential that polysaccharide has, or polysaccharides have. But of course, there are also many limitations, and also the oil polymers, the plastic things. Now the society is becoming more and more aware about microplastics, for example. Yeah? but we don't have actually a clear definition of what is a plastic, right? I mean,
for the general public, now if we move to general public, it's an issue which is of great interest for me. I'm working in this area. I'm managing a group where I'm living in the southern part of France of scientists who are giving lectures for the general public. So I'm coordinating this, and of course I'm participating as a scientist, and I'm speaking about plastics. Of course, there is a huge misunderstanding of what is the plastic, and to be honest, it is a very bad name, plastics. For a normal person, not a scientist, not having any knowledge about polymer science, a tire is not a plastic, for example, but a tire is a polymer. So plastic is not a good term, and it is inducing a lot of confusion in the mind of people. But the problem can be or is in polymer. When you were speaking about microplastics, it is indeed plastic in general, and plastic pieces is a deep problem. Usually, everybody probably is aware of the danger of plastics in the sea, okay, in the oceans. Okay, we are speaking a lot about this. But what is emerging now is the danger of plastic in the soil. Mm-hmm. And this also has a deep effect, and there are more and more studies on this. And the fact that these materials are biodegradable, so it can be coming from polysaccharides, is half solving the problem, because they are containing a lot of additives.
Yeah,
and that's a bit the problem. That's a bit of the problem. And it's not because it is bio-based that they are additive-free. You know, to process a polymer, there is no way. You have to add additives to put a color, to have the right properties, to help the processing. And these additives, they are not extremely nice. And in addition, they are undergoing chemical reactions during the processing. And you have hundreds of low quantity of potentially dangerous chemical substances.
Patrick, you mentioned about this interaction with the public. I mean, there are many people that don't know what a polysaccharide is. I mean, there are also not only general public, but also scientists. Some scientists, they need to look to understand what a polysaccharide is. Even people working with funding they don't know what a polysaccharide is. So it's interesting you said you have an initiative about going to the general public. Can you tell us a little bit about this initiative? And I'm also curious to know how people are reacting to this. How you get them interested, and what is their reaction?
Okay, this is an initiative which is located in the one small region where I'm living, in the southern part of France, near Nice. About 80 scientists, all disciplines, can be economics, physics, chemistry, whatever. So about 80 scientists are volunteering to deliver talks, conferences to the general public. So the rule of the game is that this should be understandable by a person without any specific knowledge about science. And this is, I can tell you, extraordinarily complicated to give a lecture on our field, thinking that in front you have persons who knows nothing about what you will speak about. And this is very complicated. It is, all my colleagues are saying the same. It takes a lot of time to prepare such a talk, much longer than to prepare a scientific talk. Because there, when we are speaking at a conference, we know that the others, they will understand the word you're using. But there, you are in front of persons who don't have the language, and you have to be very careful. So that's the challenge is there. Now it is going well. We last year, this year was a special year, because of course about two-thirds of the conferences were cancelled. So I cannot tell. Last year we gave talks and attracting about 3,000 persons, we're in various places, and we go to villages. We are going to
3,000.
Yeah, about this. And we are going to villages. We are going to very small cities. We are not only going to Nice or to Cannes or we are going to, and we are in a department in an area with mountains. So sometimes we have to spend the night simply to give a lecture. It's not very far, but in winter you may have snow. So it is okay. It's complicated sometimes, but it is working, and there is public, and there is a public on topics which are very, very varied, and there are many different topics. It goes from pirates in Middle Age in the Mediterranean Sea to exploration of the moon, or I don't know, everything.
And you were one of the pioneers, I mean, in bringing collaborative efforts in European scale, and IPNOE is really a sign of the success of your initiative. I'd like to know a little bit, how do you see the future for these collaborative efforts, Patrick? You mentioned that about interdisciplinarity and so on, but how you see the future? How, if you would give a message in a bottle to the future, I mean, what could we now do in order to make science more successful?
There is one word for this: time. To think that you will build a durable collaboration between research groups by giving a project for helping this building with a duration of 3 years is just a joke. It takes a very long time. It takes a very long time because you need to build what I was sometimes describing as an area of trustiness. It means that when you are in a group of, I don't know, 20, 30 scientists coming from different labs, it's extremely difficult to give your ideas, to say, I have an extremely good idea. Why not to try this? Because there is always the risk, because there is competition between scientists. There is always the risk that your idea might be stolen, that somebody will be quicker than you and will publish before you. Let's say things as they are. And this is what is taking time, to start to trust, to be confident, so that you can start to build project. It's very easy to build a project with somebody you know, or on a very small topic. So you meet somebody, you say, you're doing something on physics, I'm a good chemist. Why not to join and build something else? This is very easy. It is touching, it is only a gain. It's a win-win situation. But when you build a network as IPNOE, that you start to discuss with groups which in principle could be your competitors also, then that's much more complicated. So you need time. You need a network that, the time frame that the European Commission was giving and is still giving is, to my knowledge, too small. I know that in States or in Japan, they are building sort of groups like this with 10 years visibility, and I think that's the right time. 10 years is the right time, but a few years, it's very complicated. Before IPNOE, I was a coordinator of a European project, which was also a network. And it was a total failure. I didn't manage. Each of the group collected the money and worked on what they like, but there was nearly no connection. So sure, we wrote a very nice final report showing how we were good, but the reality is that we were very bad. And I was not able to manage. So this lesson, I didn't forget when IPNOE was built. I knew that they were, and you need money for research. When IPNOE, these networks of excellence, that was a good idea, but full of traps. One of the traps we tried to avoid was put by the European Commission itself. And they said, okay, we will give you money for organizing the network, not for doing research, because we know you scientists. We will give you money, and then you will spend all the money doing research, and at the end, there will be no network, which is not 100% wrong. But it is impossible to build a network only by giving 5 million euros to lawyers for building nice statute or whatever. So we had to be, let's say, creative to transfer money for lawyers to money for scientists without telling. Okay, so that was a bit complicated, but it was very important that the people, they had, all my colleagues and me included, we had money to start making collaborations on topics we liked. And this is why EPNOE still exists now. Okay? It is still exists. We started at 16. We are at, I don't know, 40, 42 partners.
43 now and growing.
43, okay. Okay, 43 now. And that's great. And you know that's absolutely perfect.
Yeah. Patrick, as a final question, I would like to know, if you would meet yourself, let's make an exercise here. you would meet the young Patrick today.
Yeah.
You know, the young postdoc that went to the US. And you would give a message to the young Patrick about his future career in science. What would be that message?
Do what you like. Do what you like. That's what I was pushed many times to do things that I felt I didn't like this, and I never did it. It caused me. I had a lot of problems with this, but sometimes. But I did what I like, and I think that if you trust what you like, you may fail. I failed a lot. You know, I went into areas where clearly it was going nowhere. And that was a failure. Okay, I wrote 1 or 2 papers and that was, okay, dead end. But do what you like, do what you like. Don't hesitate, do what you like. And if you have nice persons telling you or forcing you to change, think twice. Okay.
Okay, thank you very much, Patrick. It was
a pleasure.
Really a pleasure to talk to you. And I'm very glad that you could open this first edition of the EPNOE Talks. I hope we can have other interesting talks as we had with you now, and we wish you success in your new projects and your new, would say, initiatives that you are starting now with this popularization in science and additives in plastics and so on. Thank you so much. Thank you.
Thank you very much, Pedro. Bye-bye.
Bye.